Today we are going to learn about the current expression in the MOS transistor or current expression in the MOSFET transistor. So this diagram is the three-dimensional view of the MOS transistor. As you already know, MOS transistor will have three different terminals. One is source terminal, another is gate terminal, another is drain terminal. So here, in order to flow the current between the source to drain, first of all, what we have to do, we have to create a channel. Underneath of the gate terminal. So for that, what we have to do, we have to create a channel underneath of the gate terminal. So for that, what we have to do, we have to apply the positive potential. First of all, we have to apply a positive potential on top of the gate. So if we apply positive potential, then what happens? See, this gate terminal is a metal. It is a metal. Gate terminal is a metal. So if we apply positive potential on the gate terminal, then the entire plate or entire metal will become positive charge. Entire metal, like this. So you already know from the basic phenomena, positive will attract the negative electrons and negative electrons will attract the positive poles. So this is fundamental physics. Okay, so as a result, what happened? The equal amount of the electrons will attracted from the source terminal, from the drain, and as well as from the substrate. So this is called channel. Okay, so after getting the channel, the current will travel from the source side to the drain side based on the potential difference between source and drain. So for that, that gate positive potential is called threshold voltage to establish the channel. Okay, so now what we have to do, we have to derive the current expression for the MOS transistor. See, if you observe this structure, see, this is a positive potential plate and this is the negative potential plate, and in between there is a material is called oxide material. What is this? This is called oxide material. Oxide means what? It is an insulator. So in between gate and source there is a material that is called oxide. That is silicon dioxide, SiO, which is also known as insulator. So if you observe this structure, how it looks like, one metal and one substrate or one channel. In between there is a insulator. And see, this is a gate and this is a substrate or it is a channel. So this plate is having positive charge and this is having negative charge. So now, after applying positive voltage, this MOSFET is looking like a capacitor. So if you find out the current expression for the capacitor, is nothing but the current expression in the MOSFET. Okay. So from the physics, what is the current expression in the capacitor? Current expression in the capacitor is nothing but that the charge induced in the capacitor divided by the transit. So T is nothing but transit. Q means charge induced in the capacitor. So if we apply the same formula into the MOSFET, then we can derive the current expression in the MOSFET also. So here current expression for the MOSFET is nothing but I, but here it is not direct I, but it is the current travel from the source to drain. So that's why we will note it as IDS, which is nothing but what? So here in this normal capacitor, the current expression is equal to Q, means charge induced in the capacitor. But the current in this MOS transistor is what? Charge induced in the channel. So that's why we will write IDS expression as IDS is equal charge induced in the channel. Charge induced in the channel divided by the transit which is denoted as Q. Sorry, which is denoted as tau. And this one is nothing but Q. Charge induced in the channel is nothing but. Okay. Now our target is what? We have to find out the current expression in the MOSFET. So which is nothing but the IDS is equal to charge induced in the channel divided by the transit time. So once if you find out the expression for charge induced in the channel and the transit time, then our current expression will be figured or found. Now first of all we have to find out the expression for the transit time. What is transit time? Transit time is nothing but to see electrons are traveling from the source side to the drain side like this. Electrons are traveling from the source side to the drain side. Here transit time means what is the time taken? What is the time taken by the electrons to travel from the source to drain? Understand? Transit time means what? What is the time taken by the electrons to travel from the source side to the drain side? So that's why. So the transit time will be normal time will be written as the length of the channel and divided by how much velocity each electron has. See, this L is nothing but the length of the channel. See here we can see that this is the length of the channel and this is the width of the channel. So transit time means what? The time taken by the electrons to travel from the source to drain. So that's why from the fundamental physics formula, time is nothing but L by V, means the length between the source and drain and how much velocity the electron is having. That's why we will write it as a V. So we will notate this one is the first expression. This one is the second expression. Now we have to find out what is called V. Now we have to find out the expression for V. V means what? Voltage. How much voltage we are applying. So voltage means nothing but, sorry, it is not voltage. V is nothing but the velocity of electron. So velocity of an electron is nothing but the mobility of the electrons and the applied electric field. Means if you want to find out the velocity of anything, then how we can find out the mobility of that thing and how much energy it is having. So here V is equal to nothing but mu E. So here mu is constant. Why? Because it is fixed for mobility, is fixed for electrons and as well as hole. And here E means what? Electric field. E means electric field. So electric field formula is what? Electric field is nothing but, from the fundamental physics formula, is nothing but E is equal to V by L. So here L is the length of the channel and V is the voltage applied between the source and the drain. L is the length of the channel and V is the applied voltage between the source and drain terminal. So that's why here V we will write it as VDS. Okay, so this is what this is. So now we substitute E in third expression, then it is nothing but mu into VDS by M. Suppose I consider this is 4. Now substitute this fourth expression in the second expression. Then tau will become, see, it is L by mu into VDS divided by. So if you bring L upside, then it is tau is equal to L square divided by mu into VDS. So this is expression number 5. Now tau is completed. Now what we have to do? We have to find out the expression for charge. Charge means what? Q. Q is nothing but what? Charge in the capacitor is you can written as capacitance of capacitor and the applied voltage between the capacitor. This is the fundamental physics formula. Charge in the capacitor. Okay. Now, what we have to do? We have to find out what is the charge in the capacitor. This MOSFET capacitor. So that's why we will write it as charge is equal to what? Charge is equal to capacitance. Here we will call it as a gate capacitance. Gate capacitance, and is the nothing but voltage applied for the MOS transistor. So here, for getting the positive voltage, we will apply source to drain. This is called VGS, and to flow the current between the source to drain, we will apply another potential between the source and the drain. So this is nothing but VDS. Okay. So two voltages we are applying. Remember this. Now we have to find out first of all, we have to find out the voltage. So since we are applying two voltages, for MOS transistor to flow the current. So that's why we have to take the average of this voltage. So here, in order to take the average of two voltage, first we have to find out what is the supporting voltage at the gate, at the source side. So here we just remember at the source side, at the source end, the source side, the channel support voltage. This is nothing but VGS minus. Why we are taking the supporting voltage? Because if suppose if the VGS is equal to suppose say 5 volts, so here the minimum threshold voltage is required to establish the channel. So suppose for example 1 volt is required to establish a channel, then effectively you can have only 4 volts. Means 1 voltage is dedicated for creating the channel. 1 volt is dedicated to create a channel. That is the reason we have only 4 volts effectively in order to enhance the channel width. So that's why at the source side we have the channel support voltage is VGS minus VGS. Similarly, at the drain side, the channel supporting voltage, is nothing but VGS minus VTH minus VGS. So these are the effective voltages that we can have in the R. So then what we have to do, we have to find out the average of these two voltages. So average, if you take average of these two voltages, so two voltages are what? VGS minus VTH plus VGS minus VTH minus VDS divided by 2. So if you find out the solution, if you expand this, VGS minus VTH minus VDS divided by, this is the average voltage. Okay. So V is over. We have found out the V. What is the V? VGS minus VTH minus VDS by 2. Then what we left? We have to find out the CG, means capacitance, gate capacitance. So CG. So C means what? The general formula is what? C is area by thickness into epsilon. Epsilon means what? Capacitance. Capacitance is formula is what? Area by thickness into the permittivity of the capacitance. Here, see here the area of gate terminal is what? W into L. And the thickness is what? D. Oxide thickness. So here CG will becomes epsilon into WL divided by. So here permittivity is again written as epsilon naught, air permittivity into epsilon insulator into WL by D. Okay. So this is the entire, this thing can be again rewritten as CG is equal to C naught. You can write the C naught also. If you want, we can write, otherwise you can keep this concept. You can keep this. now Cg is also over and L is also over. Then what is the Q? Q is nothing but Cg. What is Cg? Epsilon naught, epsilon insulator into WL by D into V. What is the value of V? We have already seen that average of VGS minus VTH minus VDS by 2. So Q can be V is what? VGS minus VTH minus VDS divided by this is Q. Now what is the I? I is nothing but what? What is I? Q by V, Q by tau. So what is Q value? Epsilon naught, epsilon insulator, WL by D to VGS minus VTH minus VDS by 2 divided by tau. What is the value of tau? Tau is nothing but what? L square divided by into VDS. So if you do some simplifications, you bring this VDS upside and L, one L and one L will be cancelled. So if you simplify simple mathematics, you do some simple mathematics, then your IE will become mu into epsilon naught epsilon insulator into W by L into VGS minus VTH into VDS minus VDS square by 2. So this is the expression. So this is for the current expression. Current expression of the MOSFET system. This is the IDs. Okay. Thank you.